Okay, class, we're starting on section 4.4, multiplying decimals in circumference of a circle. Section A, multiplying decimals. Multiplying decimals is similar to multiplying whole numbers. The only difference is we place a decimal point in the product. Okay, now step 1, multiply the decimals as though they are whole numbers. Step 2, the decimal point in a product is placed so that the number of decimal places in the product is equal to the sum of the number of decimal places in the factors. Now, I will give you a clear definition for that as we scroll down here. We're going to skip over these examples. And let's go down here to example 1. So what step 1 is basically saying is this here. We're going to take this 45.9 times 0.42 and make it 459. We're going to drop the decimal times 42. 2 times 9 is 18, carry a 1. 2 times 5 is 10, plus 1 is 11. 2 times 4 is 8, plus 1 is 9. Put our 0 here. 4 times 9 is 36, carry our 3. 4 times 5 is 20, plus 3 is 23. Carry our 2. 4 times 4 is 16, plus 2 is 18. Now we add. 8 and 0 is 8. 6 and 1 is 7. 9 and 3 is 12. Carry our 1. 1 and 8 is 9. Bring down our 1. Now, to determine our final answer, we count the total amount of digits we have behind the decimals from the product. So with this first one, we have 1. The second one, we have 2. So we have a total of 3 digits behind the decimal. So we must have 3 digits behind the decimal in our final answer. So again, our final answer here would be 19.278 because we must have 3 digits behind the decimal. Okay, now we go to number 2. Again, we drop those decimals. So we have 112 times 6. 6 times 2 is 12. We carry our 1. 6 times 1 is 6, plus 1 is 7. And 6 times 1 is 6. Now we count how many digits we have behind the decimal. We have 3 here and 1 here, so we have a total of 4. But if you notice here, we only had 3 numbers. So whenever you have less than the amount of decimals you had in the original problem, we will add zeros in front of it till you have that exact number. So we have 4 digits behind the decimal. This will give us 4 digits behind the decimal, but we must also put that 0 in front of the decimal. So it'd be 0.0672. Now we go to number 3. We have 721 times 48. 8 times 1 is 8. 8 times 2 is 16. Carry a 1. 8 times 7 is 56. Plus 1 is 57. Now we add a 0. 4 times 1 is 4. 4 times 2 is 8. And 4 times 7 is 28. Now we add all these values together. We have 8. 6 plus 4 is 10. Carry our 1. 1 and 7 is 8. Plus 8 is 16. Carry our 1. 1 and 5 is 6. Plus 8 is 14. Carry a 1. 1 and 2 is 3. So now we count how many digits we have behind the decimal. It's only 4. So our final answer must have 4 digits behind the decimal. So it'll be 3.4608. Now we come to number 4. Still, let's drop these decimals. We have 86 times 92. 2 times 6 is 12. Carry our 1. 2 times 8 is 16, plus 1 is 17. Put a 0 here. 9 times 6 is 54. Carry our 5. 9 times 8 is 72, plus 5 is 77. Now we add. 2 plus 0 is 2. 7 plus 4 is 11. 7 plus 1 is 8, plus 1 is 9. And we bring down our 7. We add 2 digits behind the decimal. So our final answer must have 2 digits behind the decimal. So it'd be 79.12. Now, we could scroll down to our next problem. It says multiplying decimals by powers of 10. It says look for a pattern in the following products. Now, instead of going through the pattern, I just want to talk you all through this. What we have here is 6.484 times 10. We're doing the powers of 10. Now, powers of 10 are 10, 100, 1,000, 10,000, and so on. It's not 10, 20, 30, 40. So when you have that, like here we got 10, 100, 1,000, 10,000, 100,000, and we know we'll go to the millions. What happens is this here. Whenever you multiply any decimal by 10, or the multiple of 10, you count how many zeros you have, and that's how many places you move it to the right, your decimal to the right. So here we have 1 0. So we'll move this decimal one place to the right, and that'll give us 64.84. Here we have 2 zeros. So we'll move this decimal 2 places to the right, and that'll give us 648.4. Now we have 1,000. We will move this decimal 3 places to the right. So it'll be 6,484. Now, what we have here, we have 4 zeros, but we only have 3 digits behind the decimal. So we still will move this decimal 4 places, but we will put in a 0 to represent that place that we didn't have. So it'll be 64,840. And the same thing with the 5 digits. We'll move this 5 places, and we'll put in zeros to cover the places that we didn't have numbers for. Now it says here, move the decimal point to the right the same number of places as there are zeros in the power of 10. Okay, now we're going to move down to the next problem. It says look for a pattern in the following products. Okay, now we multiply by the powers of 10. Now we're going to deal with the powers of 10, but going on the other side of the decimal. So the powers of 10 goes 0.1, 0.01, 0.001, 0.0001, and so on. Now what you notice here, this is 1/10, 1 100th, 1 1,000, and 1 10,000. Then you know you'll go to 1 100,000, and so on. So now whenever you multiply by the decimal power of 10, you have to move your decimal to the left. How many numbers you have behind the decimal. Like here, we only have 1 digit behind the decimal. We move it 1 place to the left. So it'd be 4.31. Here we had 2 digits behind the decimal. We'll move it 2 places to the left, which will give us 0.431. Here we had 3 digits behind the decimal. We'll move this decimal 3 places to the left. So it'll be 0.0431. And then here we have 4 digits behind the decimal. We'll move this decimal 4 places to the left. So we have 0.00431. Now when we multiply by the powers of 10 that was in front of the decimal, remember we moved it to the right, and when we didn't have enough places for the decimal, we put zeros behind the initial number. But here we will have to put zeros in front if we don't have enough digits to go where the decimal is going. So now it says multiplying decimals by powers of 10 such as 0.01 and so on. It says move the decimal point we moved it to the left, the same number of places as there are numbers. I would say numbers behind the decimal. Okay, now we scroll down to example set C. Now we had negative 23.7 times 10. Remember, this is a power of 10 in front of the decimal, so we'll move it to the right one. So it'll be a negative 237. Next, we have a negative times a negative, which we know is positive. 203.004 times 100, we know will give us 20,300.4. Because we have to move that decimal 2 places to the right. 1.15 times 1,000, we'll move it to the right 3 places. That'll give us 1,150. 7.62 times 0.01, you know we have to move it 1 place to the left. So it'd be 0.762. Now we scroll down here to number 5. We have to move it to the left 2 places. So we have 0.019. Number 6, a negative times a positive, we know is negative. And we add these three digits behind the decimal, so we have to move the decimal 3 places to the left. We know it's assumed to be a decimal after this 2, so our answer would be a negative 7.682. Now class, we needed to scroll down to number 7. It says in 2004 there were 76.2 million families in the United States. Write this number in standard notation. Standard notation is the regular way we write numbers. 76.2 million is 76,200,000. Now I know you all heard when it said that a person has 2.5 million, that's 2,500,000. So now we go here to number 1. It says evaluate 7y for y is equal to a negative 0.028. So what we would do is we would substitute negative 0.028 in for y. So now the first thing is we know a positive times a negative is going to give us a negative. So what we need to do is multiply these numbers. Now when we drop the decimal, we're going to have a longer number here than we have here. So let's write it like this. The longer number first, smaller number second. That'll make it easier to multiply. 7 times 8 is 56. Carry our 5. 7 times 2 is 14. Plus 5 is 19. Now we add 3 digits behind the decimal. So it'd be 0.196. But we know it has to be negative. Now we go here to number 2. It says, is negative 5.5 a solution of the equation? Negative 6, and this negative 5.5 will substitute in for x. And that equals 33. So we know a negative times a negative is positive. So we could drop this decimal and take 55 times 6 to see if it'll give us 33. 6 times 5 is 30, carry your 3. 6 times 5 is 30, plus 3 is 33. Now we have 1 digit behind the decimal, so we know 33.0 is the same as 33. And 33 does equal 33, so your answer is yes. Now we come to section E, finding the circumference of a circle. The distance around an object with straight sides, a triangle, rectangle, etc. is called the perimeter. Now, the distance around a circle is called the circumference. Now, circumference is just a fancy way of saying the perimeter around the circle. Okay, now the diameter is the distance from one end of the circle through the center of the circle to the other end of the circle. Okay, now as you see here, this is going from one end of the circle to the other end, but it must go through the center of the circle, because like right here, I could go, this is one end of the circle to the other end of the circle, but since it does not go through the center, this is not the diameter. And also the diameter cuts the circle in half as well. Now the radius is just half the diameter, half the diameter. So it basically goes from one end, goes from one end of the circle to the center of the circle. So again, it's half the diameter and it goes from one end of the circle to the center of the circle, and that's the radius.